Okay, go ahead.
Let me share my screen, Karthik. Karthik, the question is, there are 4 people on a bridge. The bridge at max can hold 2 person at a time. It is very dark and only one flashlight is available. Let's say the 4 people are A, B, C, D, and each takes their different times to cross that bridge. A takes 1, B takes 2 minutes, C takes 8 minutes, D takes 10 minutes. So let's say this is the bridge. And if they want to cross from this point 1 to this point 2, with this constraint, what will be the minimum time they can cross this bridge, the bridge, to reach to the P2 point?
So let me repeat the question before I answer. There's a bridge, 4 people need to cross it, but the bridge can hold only 2 people at once. And each person takes a different time to cross. And why do we need a flashlight? Where does that come in?
It is very dark.
So they can't cross without a flashlight?
Maybe you can consider that flashlight is irrelevant. But it is very dark and one flashlight is available. So to cross, it is required. Even if you neglect, it won't change the problem statement.
So let's assume there's no flashlight that is required. People can walk. There are lights on the bridge or something. Okay. So they need to cross from one side to the other, A, B, C, D. So basically, it's just an ordering problem, I think. If you find the right order of A, B, C, and D, there are different combinations, NCR, according to mathematics, right? So, or actually 4 factorial combinations in this case. A, B, C, D, A, B, D, C, like that, right? A, C, something else, B, D, A, C, D, B, A, all these combinations. You need to find the shortest among all of them. This is not a programming question at all, is it?
No, it's like an open question.
Okay.
So basically, so given all these constraints, what will be the least time taken for all 4 to cross to the peak point?
Right. I understood that. What I'm trying to say is that the first step is to recognize that it is just a question of finding the right order.
Yes.
Because if you select an order, based on that order, the first 2 people who cross, as soon as there's available space, the 3rd person will cross, which is as soon as one of the first 2 people reaches the end, immediately the 3rd person will start. There's no need for him to wait.
Okay. Yeah, that's where it is very dark and only flashlight is available comes into picture, Karthik. So if without the flashlight, the other person can't come. It is very dark. So the flashlight is mandatory for this problem. Sorry, I didn't rephrase it correctly. So,
and can you shine the flashlight from the end, or it has to go along with the person who's crossing?
Consider it is like a very basic start. So going with that, you need that. It's not like very high beam.
Oh, so that means 2 people need to go together. Then one of them needs to bring back the flashlight. Okay, got it. And then, yes, so that's the only solution possible. And the person who's going to come back should be the fastest person, who is A, who takes 1 minute to cross.
Okay. So how will be
so let's, so let's assume B and A go together. Right? It'll take 10 minutes to reach. Right? A can cross in one.
A crosses in 1 minute, B takes 2 minutes, C takes 8 minutes, D takes 10 minutes.
A cannot be asked to walk slowly to match D.
No, if A and D walk together, A takes 1 minute to cross and D takes 10 minutes. Obviously, A needs to match that speed. Yes, he needs to match that D speed. Whoever is partner, who the fastest guy needs to match the otherwise they both.
Exactly. Exactly. So first let's get the slowest guy across. D
Okay.
and A will go together. That will take 10 minutes.
Okay, Karthik.
And anyway, D is going to take 10 minutes, whether he goes early or late, so we can't avoid it. Everyone needs to go. So first D and A go, then A comes back.
Totally it will take 11 minutes.
11 minutes. Then C and A go, which is 8 minutes. Then again, A comes back in 1 minute. Then A and B goes. Yeah, this is 9. Next, A and B is 2 minutes. So the total is what? 22 minutes. Now, before I confirm, let's just revisit.
It is totally, your current solution is 23 minutes.
22, no?
So first iteration, it will take 10 minutes. To come back, it will take 1 minute, I think 11 minutes. So C plus A, if it goes, means it will be 9 minutes. So A plus B, they will finally reach 20 plus 22 minutes. Yeah, sorry.
No problem. So let's see if, so far we have found a solution. Let us see if there's any other possibility, any other way of doing it. You can't have more than 2 people go at once because the bridge can't support it. You can't ask someone to cross from this side to that while someone else is crossing from that side to this because there's only one flashlight. You can't tell them, we are leaving now, wait 5 minutes and start. You can't say that to the remaining people. Because if the flashlight constraint was not there, suppose it is daytime, then A and D can go, and either the people on this side can see when they have reached the other end, or even if they can't see, they can use a timer and say, okay, we are going after so many minutes, you start. And in that case, we don't even have to make one person slow to match the other person. But given this, there's only one flashlight. If you send only one person in the first step from the first side to the other, then it doesn't make sense because the flashlight is stuck
unnecessary go back.
Yeah. You can't even go without a flashlight. So the only first step, there's only one option, which is 2 people go. And who should come back? Obviously, the fastest person should come back. That is not a variable that can be changed. Now, the order can be changed, but it doesn't make a difference because 10 plus 8 plus 2 is same as 10 plus 2 plus 8 is same as 2 plus 8 plus 10, any order. So yeah, this is the solution, I would say.
Okay. Let's try few combination. Let's say A plus B goes. It will be 2 minutes, Karthik. Then to come back, it will be 3 minutes. I am sending. Now, I will send A plus C or A plus D, whatever. 8 plus 1, 9. Then finally, A plus D. 10. So finally, we are getting here also 22 minutes.
Yeah, because you're just changing the order, right? The first one was 10 plus 8 plus 2 plus 2 reverse journeys. Here it is 2 plus 8 plus 10 plus 2 reverse journeys. So it's the same thing. It's like A plus B plus C and C plus B plus A, which is the same.
Yes. But the optimal solution is much lesser, Karthik.
Okay, let me think about it. There are 4 people on a bridge. Like when you say on a bridge, you mean they are on one side of the bridge. They're not already on the bridge, right?
Yes, yes. For your representation, I had it. So at P1, A, B, C, D are there. The destination is P2. And this is the bridge.
I'm having trouble with the screen share. It's coming and going.
Okay, let me send
Wait,
this.
wait. I can see it. I can see it. Leave it, leave it. There are 4 people on the bridge. The bridge at max can hold 2 persons at a time. It's very dark and only one flashlight is available. A, B, C, D are the 4 people. Now let's look at the options. First step, what can we do? If only one person goes, it doesn't make sense. The flashlight is stuck, irrespective of who that person is. And he has to come back, in which case you have accomplished nothing. So first step, only one person going doesn't make sense. 3 people cannot go because the bridge will collapse. So 2 people must go in the first step. And they have to, the faster person needs to slow down to match the slower person. Otherwise, the slower person will not be able to walk without the flashlight, correct?
Yes.
So they have to go together. Now, do we need to make 2 return trips is the other question.
Do we need to?
No, I'm just thinking aloud. If I have a question for you, I'll ask you, but until then I'm thinking aloud.
Sure.
The question is, there are 2 return trips here. Do we need to do that? Because there are 4 people. Yeah.
2 return
You
trips
need,
will happen.
Sorry?
2 return trips will happen. Should happen.
Okay. So that is not the thing that can be optimized. The other thing is, the person who is returning, should it be A, the fastest person? The slow person returns. The return journey will be slower, but is there any advantage we get later on? No. And if we pair the fastest and the slowest person together, A and D, on the first journey, A is going to waste a lot of time. But that's okay. There's no penalty for A wasting time. Because anyway, until both of them reach the other end, even if A reaches, there's nothing he can do. He has to wait for the other person to reach. Yeah, so that is one. So if we make one of the slower people come back, suppose B goes, let's say B and D go in the first journey, which is 10 plus 2. No, not 10 plus 2, just 10. And then return is 2. Are the trips sequential or can they overlap in some way? They can't overlap because if there are 2 people or 2 groups of people at different points on the bridge, one of them doesn't have a flashlight. And you can't shine the flashlight from one end to the other. You can't throw the flashlight over the bridge or anything like that, right? You have to take it with you.
Yes.
And all need to cross, right? Not just some.
All needs to cross. Yeah. All. So basically, whoever are in P1 needs to go to P2.
Give me a hint. Just lazy. That's why I'm asking you.
Karthik, so basically, the hint is about ordering. Just shuffle the order. Like you said, what if we send a couple of what if slow moving guy or using of fast moving guy? Think about the order. The order is the key.
Okay. Let's say we send the 2 slowest people first, C and D. Let's run through this.
Okay.
Even if this is not the right answer, maybe running through it might give me some idea. So we send C and D together, which takes 10 minutes.
Who will you send it back?
Yeah, C will come back.
Okay.
And then, so that has taken 10 minutes. And then 8 minutes return trip. So 10 plus 8, 18. And then if C crosses again, it's going to take at least 8, which is 26, which is already worse than what we have. So let's consider a different approach. Instead of sending C and D together, let's send A and D together as in the original solution, but ask D to come back. No, that also doesn't. I don't know, Satish. What's the answer?
Do you want to try the order again, Karthik?
So what I was considering was, there are two options I was considering. First option was send the two slowest people together. Right? That didn't work, as we saw. You agree with that?
Sending two slowest guys? Oh, yes, Karthik. Because it will take more time to go also while coming back also, since both are having considerably slower case, it will be bad.
Yeah. Okay, so then that doesn't work. So then let's try two more options. One is you send the two fastest people together, A and B. They cross in 2 minutes. Then A comes back in 1 minute. Doesn't make sense for B to come back because he'll be slower. So A comes back in 1 minute. We are at 3. Then A escorts C, which takes 8 minutes.
Just a minute, Karthik. You just think it through, Karthik. Give me just a second.
Sure. So A and B go together 2 minutes. A comes back in 1 minute, total 3 minutes. A escorts C. That takes 8 minutes. So 3 plus 8 is 11. Then A comes back, which is 1, 12. Then D and A go together, which is 22. Yes, Satish, I tried 3 different orders. One was the opposite of the original order. One was have a different person come back. One was to pair the fastest and the slowest guy. One was to pair the two slowest guys. But in all the cases, I'm not getting a better answer than 22.
Okay, let me give it a try. Let's send A plus B together, Karthik. So that will be 2 plus 2 minutes to reach. Just a minute. I got confused. Then I send B again back.
Okay.
So that will be 4 minutes. Then I send C and D. It will take 10 minutes. And I will send B back this time.
No, you can't send B back. B is on the first show.
No.
If C and D have gone, either C or D or A have to return. First A and B went, then who returned, A or B?
Let's assume A returned.
Okay.
B is...
So now A, C, D are here. So if A gives the torch to C and D and asks them to go together,
it
now
will take
A is left.
Yeah,
it'll take 10 minutes, then 2 to come back, which is 12. Who is going to come back?
B.
B is going to come back, which is going to take 2. Okay. A and B are going to go in 2. Oh.
So we optimized.
Aha, this is very smart. So basically the two slowest people should go together. So you have only one long trip. You don't have 2 long trips. Right? In my solution, you had to do 8 plus 10.
Yes. Even
in your solution, you're doing max of 8, 10. Nice.
Even I thought this will be actually this one I didn't crack it. It was an online answer. Actually, this was my first solution. So as soon as we saw this problem, we always optimize with the fastest moving guy, go back, go forth, come back, go forth, come back. In that way, we thought, okay, at least we are optimizing the individual coming back time. But
Yeah.
we always forget the max of.
Nice. I thought I considered all the possibilities. Nice. Okay, any other comments about this or the way I answered?
Since I also came up with the same solution, when I actually thought, actually this question is about 1 to 5, 8 minutes, Karthik. I actually, by mistake, I made it 1 to 8.
That's okay.
Still, when I came with this approach, I was shocked that it can be still optimized. I thought even if we change the combination, it will be always same, because our base assumption was always the fastest moving guy will be coming reverse as an individual.
Yes.
So yeah, Karthik, it's good that even you thought this will be the case.
Right.
It's good learning.
Yeah, when I gave up, okay, so any other feedback on the way I approached it?
Actually, this part was very smart that you figured out. I was saying that by mistake, I was saying this is not relevant, right? Even without that problem will work. If it is not there, it is very simple. So, we can just optimize it like worst level with next worst level, we'll send it. Then
yes.
So it will be like just reverse sort order. So it will
Right.
be our fastest way. So
Right.
this was a very good finding out.
Any other comments?
The way you handled all the cases, like can the torchlight be high beam? But when I came across this problem, even I didn't thought, okay, what if they are in part way? Like let's say since this bridge will hold only 2 people. What if those people, one of the people, the slowest person coming like 3/4 of the 1/4 of the place and throwing the torch? That case also in real time we can do that, right? Why someone will come across, they will just throw, like if he is so powerful, like half of the bits. In that way we can optimize more. So all these cases you consider, it was so good. It was good, Karthik. It was an overall good experience.
Nice. See that typically when we go wrong here, what happens is we have one assumption in mind, like you said, the fast guy should always escort someone else. And as long as you have that wrong assumption, even if you think you have tried all the possibilities, you have tried only some of the possibilities. One more thing you could have done as an interviewer, this is meta feedback to you, is when I gave up, I said I tried all the cases I don't know. You gave me a hint, right? Which is order. But when I still said I don't know, you could have given me a more specific hint, which is C and D have to take a trip together.
Okay. Oh.
Then I think, if they go first, what will happen? No, then maybe first someone will go,
actually,
then C and D.
If you remember, you took the case C and D, Karthik. You took C and D and you sent C back. Then it led to our worst case scenario.
I sent C and D in the first step, but before that, someone needs to go to the other side. Then C and D need to go.
Oh, okay. Got it.
So that's the thing, right? If you say the correct answer involves C and D making a trip together. Don't tell me whether from this side to that side to this side. Don't tell me all that. So you're giving one step of the solution. And then I can think about ordering, right? So yeah, give more and more hints.
Okay, sure. Understood.
Because if given a hint, I am able to answer, let's say. And someone else is not able to answer, even given such a specific hint. Then that's an indication, right? If you give it away, you won't know.
Yes, Karthik.
So are we done with this?
Yes, Karthik. I'm just formulating the second problem.
Don't ask me a puzzle, please. I don't enjoy this. Something to do with software.
Okay.
It can be system design, can be data structures, algorithms, knowledge of something.
Sure, we'll do that.
CSS. So shall we stop this?
Yes.